Myself, Dr. Naresh Kumar, Associate Professor, Department of Mathematics, Institute of Aeronautical Engineering, Dundigal, Hyderabad. Today, I want to discuss of linear differential equation of second order with constant coefficient. So in last lectures, we have discussed several methods of PI, particular integral. If the value of q is the function in right hand side of the linear differential equation with constant coefficient, if value of q is changed, then method is changed. So there are several type of function q is e to the power ax, that is first function, exponential function. Q is x to the power n, that is algebraic function. Q is sin ax or cos ax, that is trigonometrical function. So there are three methods are this. After it, some function are coming in multiply. So there are different methods of finding particular integral. So here I am discussing one by one each method of particular integral. So today I want to discuss when q is trigonometrical function. So there are only two functions involved in q in right hand side of the linear differential equation with constant coefficient, that is q equal to sin ax or q equal to cos ax, not tan ax, not cot ax, not other function. Only two functions are in apply there, q equal to cos ax and sin ax. So one by one I am telling about finding the particular integral of the given function. So here we will discuss linear differential equation of second order with constant coefficient. So in last lecture we have already discussed about it, but here I am also giving some introduction of linear differential equation with constant coefficient. So here d2y over dx2. In this differential equation, there is second order derivative d2y over dx2. In this derivative, differentiation of y with respect to x. Here x is independent variable and y is dependent on x. Here is using function in this differential equation, using function y is equal to fx. This function is using here. Here x is independent variable and y is dependent on x. So here first derivative, that is of second order. So here number is multiply 1. One number is multiply here. Always. In general equation, there is only one number multiply with second order derivative. Now second function is P1. P1 is number. And this multiply by first differential coefficient or first derivative. And next is P2 number. Here is only function y. Y is some function of x here. And equal to right hand side, there is q. Q is the function of x here. So this is known as a linear differential equation of second order with constant coefficient. Here P1 and P2 are constants. Constants means number, which value is never changed. That is known as a constant. That is known as a number. Number is never changed. And q is the some function of x here. Q is some function of x here. Say q equal to fx. Here we will discuss in detail how we can find the solution of linear differential equation of second order with constant coefficients. So here this is given here one equation. This is general linear differential equation of first order with constant, of second order with constant coefficient. So now solution of 1. How we can find solution of 1? So we discuss here in detail How we can find solution of 1? Solution depend on the value of q. If q is e to the power x, then we must apply case first. If q is algebraic function x square x cube x, then we apply case 2. If q is sin ax or cos ax, then we apply case 3. But in case 2, there are two cases arise. When exponential function are given, then in exponential function, there are two cases arise. So here we use here method y is equal to cf plus pi. This is the main method y is equal to cf plus pi. Cf is complementary function and pi is particular integral. So the solution of linear differential equation with constant coefficient in two parts. So first part is complementary function and second part is particular integral. If q is given in our question, then we get pi. Otherwise q is 0, then pi is 0. We cannot find the pi if q is 0 here. So then complete solution is y is equal to only cf. Only complementary function is complete solution. So here we will discuss in detail second part of solution, particular integral. To find particular integral of 1, then q never 0. Q is given some function, then we can find particular integral. If q is 0, then pi is 0. Particular integral is 0 here. So q is some function of x here that is given in our question. So I am writing here one general differential equation of linear differential equation of first order, of second order, linear differential equation of second order. So here formula for particular integral. I am using formula for particular integral, that is 1 upon ft into q. This is equation 2. We will discuss case 4. Here if q is sin ax or cos ax. This q is trigonometrical function. Q is trigonometrical function. Metrical function. Q is trigonometrical function. Means q is sin ax or cos ax. Only these two functions are there. Sin ax or cos ax there. So in this case, we use same procedure. If either q equal to sin ax or cos ax. If q equal to sin ax given, then we apply same method, and q equal to cos ax given, then we apply same method. No change in procedure. Either given q equal to cos ax or given sin ax. Both condition, we apply same procedure to solving the pi, to finding the pi. So now we know that. Here we are showing that several derivative of sin ax with respect to x. What will be happen when we are differentiate of sin ax with respect to x 1 time, 2 time, 3 time, 4 time, 5 time. Many time we are differentiating. So what will be happen? At last what we find out? Result. So we are showing in this discussion, we are showing this result. So first of all, I am differentiating sin ax with respect to xd. Here d is d over dx. d over dx. Differentiating with respect to x. So differentiation of sin ax with respect to x. We get sin ax differential is cos ax. And ax means x. Differential of x is 1 and a is multiply x, so a. So total differential a cos ax. Again 2 time differential of sin ax, d square. D square means 2 time derivative, d2 over dx2, d2. 2 time differential of sin ax with respect to x. So here again differentiating this function, cos का minus sign. Differentiation of cos ax is minus sin ax. And ax again into a. So we get here minus a square sin ax. 3 times differential of sin ax minus a cube cos ax. 4 times differential of sin ax, a4 sin ax. A to the power 4 sin ax. Because here is cos ax, differential of cos ax means minus a into sin ax. So a4 sin ax. Again differentiating 5 times of sin ax. Then we get a to the power 5 cos ax. Now we get 6 times differential of sin ax. 6 times differential of sin ax. We get minus a to the power 6 into sin ax. Again differentiating 7 times of sin ax. 7 times differentiation of sin ax with respect to x. Then we get here a to the power 7 cos ax. Next here again differentiating here 8 times differentiation of sin ax with respect to x. Then we get plus a to the power 8 sin ax. So now here we are showing all derivatives. Similarly we can do in up to n time derivative of sin ax. But we want here some results. What will be happen when we are finding several derivatives of sin ax? So here we seeing only even derivatives of sin ax one by one. So all even derivative here I am showing here. Here we see all even derivative of sin ax with respect to x. So here d square of sin ax we get minus a square sin ax. So here d4 sin ax 4 times differential of sin ax we get a to the power plus a to the power 4 sin ax. This is positive, negative, positive, negative, positive. First even term is negative, second even term is positive, next even term is negative, and next even term is positive. So we find the differentiation, even time of differentiation of sin ax with respect to x in alternative sign. First is minus sign, next is plus, then minus, plus. So what at last we find out here? So here now in all equation 2, equation 3, equation 4, equation 5, cancel function on both sides. Cancellation function on both sides, then we have sin ax is cancelled this side to this side, this side to this side, this side to this side. Function is cancellation on both sides. Then we get here d square equal to minus a square. D square equal to minus a square. Next d4 equal to a4, second derivative. So d square का whole square equal to minus a square का whole square. So square is cancel here. We get d square equal to minus a square. Here we get d square equal to minus a square. Now third derivative d to the power 6 equal to minus a to the power 6. D square का whole cube equal to minus a square का whole cube. Cube is cancel here. We get d square equal to minus a square. Next here d to the power 8 equal to a to the power 8. D square का whole 4. D to the power 8 is d square का whole 4 equal to minus a square का whole 4. 4 power is cancel out. We get d square equal to minus a square. So ultimately in our results, all derivative we see only here. Ultimately we have proved that d square equal to minus a square. D square equal to minus a square for both cases. Either q equal to cos ax or q equal to sin ax. If q equal to here sin ax, then we put d square equal to minus a square. And if q equal to cos ax, then we put d square equal to minus a square. This is condition. We have proved the condition here. So this is the condition. In both case we have same condition this. Now, in case 4, every place putting only in denominator. In case 4, every place putting only in denominator of pi, particular integral. Particular integral, there is numerator and denominator. Particular integral in two parts. In fraction form. particular integral starting in fraction form. Then numerator and denominator are there, but only in denominator of pi putting d square equal to minus a square. Not in numerator putting, only in denominator putting d square equal to minus a square. But condition is f d square equal to f minus a square. Function is d square. We get function in d square and d square equal to putting minus a square. So here I am solving one problem based on case 4. F minus a square is not equal to 0. This is the condition. F minus a square. If putting d square equal to minus a square, then total denominator not must be equal to 0. Then we apply this formula. If denominator 0, then this method does not exist. Method will be changed there. If given question q is equal to sin ax or cos ax, in both function we apply same procedure. Same procedure we apply, either q equal to sin ax or q equal to cos ax. So I am solving here one problem depend on q equal to sin ax. Q equal to here sin ax. This problem depend on this. So here solve d2 by over dx2 plus 4 dy dx plus 5 by equal to sin 2x. This is question. This is linear differential equation of second order with constant coefficient. And in this question, right hand side is also given. Means value of q is given. Value of q is sin 2x. Q equal to here sin 2x given. So a is 2 here. Value of a is 2. In general question, there is sin ax function. Function is sin ax. But in our given question, a is number. So a is number, there is given sin 2x. Sin 2x means a is 2 here. After comparison sin ax with sin 2x, then we get a is 2. So now solution here. We will discuss in detail about the solution of this differential equation 1. So d2 by dx2 plus 4 dy dx plus 5 by equal to 0. Not 0 here, sin 2x. Sin 2x. This is equation 1. Equation 1 can be written as. Equation 1 can be written as. How we can write this? Because d is d over dx. And d square is d2 y over dx2. And dy equal to here this dy. And here d square y equal to this dy. So dy equal to putting dy dx. D square y putting d2 y over dx2. Then our equation convert into this question. This is equation 2. This equation in the form of this f dy is equal to sin 2x. This is the form of the equation. F dy equal to sin 2x. This is the type of equation 3. In equation 2, we have q equal to sin ax. There are two parts of the solution. First part of the solution is complementary function and second part of the solution is particular integral. So now here first we will find here CF first. So to find CF, putting q equal to sin ax equal to 0. When we find out, we will find out complementary function, then q is must be 0. Without putting q equal to 0, we cannot find particular integrals, complementary function. So here first we find out the complementary function. So here we must putting q equal to 0. Q is here sin ax, sin 2x. So sin 2x is equal to putting 0 in our question. Then we can find complementary function. So here putting q equal to sin ax equal to 0. Then we can find CF of equation 2. So here now equation 2 becomes, when putting q equal to 0, this is equation where fd equal to d square plus 4d plus 5. This is fd, function of d. Here function of d is d square plus 4d and plus 5. So d square plus 4d plus 5y equal to 0. Here should be 0. Q here taking 0. Q equal to 0. So this result is 0 here. Now putting d equal to m and removing y from equation 2. Here y is removing and d equal to putting m. D equal to putting m and removing y from 2 from equation 2. Here this function is should be 0 here, sin x. Sin ax is 0. So now putting d equal to m and removing y from equation 2, then we get an auxiliary form of equation 3. This equation 3 here. So now equation is this. M square plus 4m plus 5 equal to 0. This equation 3. Solving equation 3. Now factorizing of equation 3. We know that equation 3 is a quadratic form. Quadratic form, we know what is quadratic form. So quadratic form ax square plus bx plus c equal to 0. This equation 4. So now comparison here, equation 3 which is auxiliary form and equation 4 that is quadratic form. Equation 3, comparing in equation 3 and equation 4, then we get the value of constants A, B, C. So after comparing 3 and 4, we get A is 1, B is 4 and C is 5. Here, solving the question 3, equation 3, apply Sri Dharacharya formula for solving equation 3. So this is the Dharacharya formula, equation 5. This is solved by, this is proved by Sri Dharacharya. So that is known as a Sri Dharacharya formula. This formula used to solve any quadratic equation, 2-degree equation, quadratic equation. So now putting value of A, B, C here, we get this minus 4 plus minus B square, 4 ka square minus 4 AC upon 2. Again minus 4 plus minus under root. 4 ka square 16 minus 5 4 ja 20 upon 2. Minus 4 plus minus under root. 16 minus 20 means minus 4 upon 2. M equal to minus 4 plus minus under root. Multiply, breaking this root, breaking. Minus 1 into root minus 4 upon 2. So minus 4. Here I am writing here minus 4 and plus minus. This root minus 1 is I and here is 4 upon 2. So 2 cancel this 2 and this 2 cancel. So here is minus 2 plus minus 2i. 2 minus 2i. Here is 4. So here is 2 only. 2. So this is 1. So here is only I. Minus 2 plus minus I. This is alpha plus minus I beta. So alpha 2 plus minus I. Because I is root minus 1 here. This is imaginary number. This is known as a iota. In complex number, we get the value I equal to root minus 1 and I square equal to minus 1. So alpha is minus 2 and beta is here 1. So roots are imaginary. Roots of an auxiliary form here, imaginary roots. So using formula for CF if roots are imaginary. So this is the complementary function formula. Formula of complementary function. When roots are imaginary. Roots are imaginary. Imaginary roots. Then we apply this formula. So here putting value of alpha and beta. Then we get complementary function. E to the power minus 2x, C1 cos x plus C2 sin x. Here beta is 1 and alpha is minus 2. So e to the power minus 2x in bracket C1 cos x plus C2 sin x. This is complement. Here C1 and C2 are two arbitrary constant. The equation 6 is complete solution of 1. Complete CF of 1, not solution. This is complete CF of 1. Complete CF of 1. Not solution of 1. This is complete CF, complementary function. Complete complementary function this. So y is equal to, this is the solution of y, one solution of y. So y is equal to CF equal to this here. This is first part of the linear differential equation of second order with constant coefficient. This is first part of equation 1, which is given in our question paper. Now finding second solution of 1 is Pi. Second part of the Pi. How we can find second part of the Pi when Q is sin AX or cos AX. So I am discussing here a special case when Q is trigonometrical function sin AX or cos AX. A is number sin 2x, sin 3x, sin 4x, cos 2x, cos x, cos 3x. A is any number that is multiplied by x with variable sin 2x, 2 multiplied by x. So how we can find particular integral? So we discuss here detail. First, which formula we applied for Pi? So this is basic formula. This is basic formula to apply find Pi. Pi is equal to 1 upon Ft into Q. This formula is very important and every step we are using this formula. So this is Pi equal to 1 upon Ft into Q. But in our question, we know value of Fd. What is Fd? Fd means function in D. So in our question, function in D, function 1 upon Fd is this. Fd d square plus 4d plus 5 into sin 2x. This is Q. This sin 2x is the value of Q and this is the value of Fd, d square plus 4d plus 5. This is equation 5. We have already proved that in denominator of Pi, this is the denominator of Pi. This is numerator of Pi. Only in denominator of Pi, putting d square equal to minus a square. A is here 2, sin ax equal to sin 2x. So a is here 2. So putting here 2 minus 2 square. D square equal to minus a square equal to minus 2 square. Where this value putting? This value putting in denominator of particular integral. There are two parts of the particular integral. This is numerator, this is NR, this is denominator dr in numerator and denominator. Putting the value of d square is minus a square, only d square, not d, not dq. In place of d square, we are putting is minus a square. A is any number given in our question q. So here is sin 2x given value of q. So sin 2x is sin ax, so a is 2. So here a equal to 2. After putting a equal to 2, after putting here, after comparing here, we get a equal to 2. So now here putting in equation d square equal to minus a square equal to minus 2 square. So what happened here? Pi equal to 1 upon Fd equal to this d square minus putting d square minus 2 square plus 4d plus 5. So here Fd, in Fd putting d square only this. So this is wrong here. Fd is not there. Now putting here minus 4 plus 4d plus 5 into sin 2x. So 4d minus 4 plus 5 means plus 1. So 4d plus 1 into sin 2x. This is the equation 7. Now in equation 7 multiply by conjugate of 4d minus 1. Conjugate 4d minus 1 is conjugate of denominator. Here is denominator 4d plus 1. So what is conjugate of 4d plus 1? Conjugate is 4d minus 1. Means its negative sign. So here 4d minus 1 of denominator of Pi. In both numerator and denominator multiply by in both numerator and denominator, then we get. So here we get 4d minus 1 upon 4d plus 1 and 4d minus 1 sin 2x. Why we multiplying this 4d minus 1? Same bracket this plus minus 1. So here we apply formula a square minus b square equal to a plus b into a minus b. This formula we apply here. So we can write here a square minus b square, a plus b, a minus b. So we can write here numerator 4d minus 1 upon 4d ka square, 4d ka whole square of 4d So here 16d square minus 1 and into sine 2x. Again putting, I have already proved in denominator, when we are getting d square, then remove d square equal to minus a square. So I am putting here d square equal to minus a square. D square equal to minus a square equal to minus 2 square, means minus 4. So d square equal to putting here minus 4 in denominator only, not numerator. So I am writing here 2 square minus 1. Same sign 2x is this. Now next one is 4d minus 1 upon, here multiply minus 4. Minus 2 2 is 4, minus 4, 16 4 is 64 and minus 1. So I am writing here minus 64 minus 1. 4d minus 1 numerator is no change. Now this sign 2x multiply in numerator. When this multiply here, so is this differentiate. This is operator here. D is differentiation with respect to x. D is operator. When any function multiply with operator, then differentiate the function. So here I am writing 4d sine 2x minus 1 into sine 2x upon minus 64 minus 1. So that is minus 65 here. Now differentiation of sine 2x, 2 cos 2x. Sine 2x का differentiation of sine 2x with respect to x, cos 2x, and differentiation of 2x is 2. So 2 cos 2x. So 4 into 2 cos 2x minus sine 2x. So 4 2 is 8 cos 2x minus sine 2x. Here is minus 65. This minus taking in numerator, then sign is change. Minus plus plus minus. So I am writing here sine 2x minus a cos 2x upon 65. So this equation 8, this is the complete pi of 1. Pi is equal to sine 2x minus a cos 2x upon 65. This equation 8. Now complete solution of 1 is given as follows. This is complete solution, y is equal to cf plus pi. So first part we have already find the complementary function, y is equal to e to the power minus 2x, c1 cos x plus c2 sin x. This is cf, first part of the solution, and second part is equation 8. So this is sin 2x minus 8 cot 2x upon 65. So complete solution of linear differential equation of second order with constant coefficient is y is equal to cf(pi). So this is complete solution. So we get complete solve the given question problem 1. Now next we want to solve problem second based on same case 4, f minus a square, f d square. Here f d square and putting d square minus a square. This is never 0. Then we apply this case. So here given question next, d2y over dx2 plus 4dy dx plus 8y equal to cos x. Solution, start solution. Same this equation I am writing here, that is equation 1. Here cos x, q is cos x given. In general question cos ax given, but here is cos x, so a is 1 here. After comparison, cos ax and cos x, comparison this, so a is 1. A cos x, so a is 1 here. Age number is 1. Now equation 1 can be written as in the form of d, derivative form, d form. D is here d over dx. Okay, and d square here d2 over dx. So putting these values in our question, we can write equation 1 in this form. D square plus 4d plus 8y equal to cos x. This is equation 2. For finding auxiliary form, then we write our question 1 convert in 2. Then we can find easily auxiliary form of 2. So here first we find cf of 1. Then putting q equal to cos x equal to 0. First solution finding complementary function. If we find out the complementary function, then q must be 0. If q 0, then we can find the auxiliary form easily. So q is 0 taking. So here q is putting 0, then we get equation 2. D square plus 4d plus 8y equal to 0. Here q is putting 0 here. Now finding auxiliary form of equation 3. This equation 3. This equation 3 convert in auxiliary form. How we can convert in auxiliary form? Putting d equal to m. D equal to m here. And removing y. Y is function. Y is removed because function never 0. But this result may be 0. A into V, I am showing that A into V equal to 0 either A 0 or V 0. Okay. But here is A is d square plus 4d plus 8. V is y. So y is function. Y is never 0. Here y is never 0. We find out the value of y and we are taking y 0. What will be happen? So y is never 0. It means this result is 0. And putting d equal to m. So m square plus 4m plus 8 equal to 0. This is equation 4. This is known as a auxiliary form of equation 3. Auxiliary form of equation 3. Solving equation 4 by Sridharacharya formula. Again apply here Sridharacharya formula. We can factorizing this also. We can making perfect square also. Any formula we apply here. First is factorizing. Second is perfect square. Third is using Sridharacharya formula. So here again we know the formula. This m equal to minus v plus minus under root b square minus 4ac upon 2a. Comparing in auxiliary form to quadratic form, general quadratic form, then we get a equal to 1, b equal to 4, c equal to 8. A equal to 1, b equal to 4 and c equal to 8. After putting these values in this formula, then we get roots. Completely root, directly we find roots. So here b is 4. So minus 4 plus minus under root 4 ka square minus 4 into a into c. 4ac upon 2a. 2 into 1. So minus 4 plus minus under root 16 minus 4 8 is 32. 32 minus 16 is minus 16 upon 2. Minus 4 plus minus root minus 16 upon 2. M equal to minus 4 plus minus root minus 16. Root minus 16 I am breaking here. This is root minus 1 into root 16. So I am writing here root minus 1 into root 16. Root minus 1 is I. I is root minus 1. I square is 1 here. Root 16 is 4 here. Every value I am writing here. I is root minus 1. I square is minus 1. Root 16 is plus 4. So this value putting here minus 4 plus minus 4i upon 2. Cancel out by 2 here. Then we get minus 2 plus 2i. This is imaginary roots. These are imaginary roots because there are two roots. So m equal to this is alpha plus minus I beta imaginary roots. Alpha is real part and beta is imaginary part and plus minus represented the two roots. So here alpha is minus 2 and beta is 2. Alpha is minus 2 and beta is 2. So using formula for CF if roots are imaginary. This is the formula, proved formula to find out complementary function if roots are imaginary. Then we apply this equation 6. So CF is equal to e to the power alpha x, C1 cos beta x plus C2 sin beta x. Alpha and beta are real and imaginary value in our given roots. So CF equal to e to the power minus 2x, C1 cos 2x plus C2 sin 2x. Equation 7 is the complete CF of equation 1 of our question. This is the complete complementary function of given question problem 2. Now finding pi of 1, apply again case 4. Same case apply here. Case is no change. Because if q is sin ax or cos ax, in both conditions we apply same procedure, same case here. Now pi, we apply this formula for pi. Particular integral equal to 1 upon fd into q. There is two part of particular integral, numerator and denominator. This is numerator and this denominator. Numerator is 1, denominator is FD, and Q is in numerator, not in denominator. So FD is some function of D. So function of D in our question is this I have writing here. So this is D square plus 4D plus 8 into cos X. In case for every place putting only in denominator, in case for every place putting only in denominator of pi, d square equal to minus a square. We have already proved this. Not in numerator, only in denominator. Fd square equal to minus fa square, f minus a square. So d square equal to minus a square, but age here 1. After comparison, age 1. So minus 1 square is minus 1 age. This is minus 1. D square equal to putting minus 1 or minus 1 square equal to minus 1. But in our question Q is cos AX and in our question is cos X. So here age 1 after comparing. So putting D square equal to minus 1 here. So D square is minus 1 plus 4D plus 8. Now 4D 8 minus 1 is 7. 4D plus 7 in cos X. This is equation 9. Now in equation 7 multiply by conjugate 4D minus 1 in denominator of pi. This is equation 9. 4D minus 7 conjugate of denominator. Conjugate of denominator. In denominator is this 4D plus 7. 4D plus 7 in our particular integral in denominator. So here it's conjugate. Conjugate means 4D plus 7 then 4D minus 7. Changing only sign there. So we apply here, here we want to apply here a plus b, a minus b formula. So again we get d square. So here 47 multiply minus 4d minus 7 of denominator. This is conjugate of denominator. Of pi in both numerator, nr means numerator. I am writing here nr means numerator and dr means denominator. Denominator. So this is the expansion of nr and dr. So pi in both numerator and denominator in 9. Then we get here 4d minus 7 upon 4d plus 7 plus 4d minus 7 into cos x. So this is the conjugate of this in denominator only. If we multiply in denominator, then also multiply in numerator. Both working are doing simultaneous. If we are multiplying only here is not multiplying, then there is mistake. At this time, this cancel out. There is no change. Last equation is equal to this equation. So 4d minus 7 and a plus b, a minus b, we apply formula. So 4d is 16d square minus 49 cos x. Again putting d square equal to minus 1 in equation 10. 4d minus 1 upon 16 into minus 1. D square equal to putting minus 1 and minus 49. So minus 1 means minus 16 minus 49. 415, this is minus 65. And this cos x, taking in numerator of the 4d minus 7, multiply any operating this function, then goes to 4d cos x minus 7 cos x. D cos x, here is d cos x means differentiation of cos x with respect to x, that is minus sin x. So I am writing here minus sin x. So 4 minus sin x minus 7 cos x. Here is no derivative. So here is not differentiate the function. So we get 7 cos x only. So here is minus 4 sin x and minus 7 cos x. So here minus, taking minus common here. Minus is common. So 4 sin x and plus 7 cos x and upon 65 minus. So minus minus is cancelled. So we get here 4 sin x plus 7 cos x upon 65. So pi is equal to 4 sin x and plus 7 cos x upon 65. This is complete pi of one equation. Now complete solution of equation 1. We have y formula. Y is equal to CF plus PI. Complementary function plus particular integral. So here we find out CF. CF is this. Equation 7 is complete CF. And particular integral is complete equation 11. So now adding equation 7 and equation 11, then we get complete solution of 1. Complete solution of 1. So y is equal to CF. This is CF. E to the power minus 2x, C1 cos 2x plus C2 sin 2x and plus 4 sin x plus 7 cos x upon 65. So y is equal to complete CF, e to the power minus 2x, C1 cos 2x and plus C2 sin 2x and plus 4 sin x plus 7 cos x upon 65. This is the complete answer. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.